Another exciting lesson. We're going to be starting Unit 8. Okay, so we're going to do an introduction to circles, reviewing them, and then also talk about similar circles and how circles are similar. So during this lesson, you're going to learn how to show that all circles are similar. Our vocabulary: a circle is a round figure in which the distance from the center to any point on the figure is the same. The radius is the distance from the center to any point on the circle. And a dilation is a transformation that produces the same image but in a different size. Dilations usually include a scale factor and a center of dilation, so we need a scale factor and a center of dilation. Okay, our parts of our circles are radius, from the center to the distance from the center to any point on the circle. A diameter is the distance from any point on the circle to another point that goes through the center. So there's the key point. Circumference is the total distance around the circle. We can think of this kind of as the perimeter. All right. So are all circles similar? That's the question. The definition of a circle is a round figure in which the distance from the center to any point on the figure is the same. Since the radius of a circle is constant, it should be similar. Similar means that the circles will be proportional to one another, so in a circle, the circumference should always be proportional to one another as well as the radii. Okay, so are these circles similar? My radius is 5 centimeters, diameter is 10, and circumference is 10 pi. Radius, 8, 16, and 16 pi. So we can simply do something like this, saying radius over circumference and radius over circumference. I can simplify both of these. So on this one I can divide both by 5. This one I can divide both by 8. And we get 1 over 2 pi is equal to 1 over 2 pi. Look at that. They're similar. We have a similar ratio. All right, so circle A has a diameter of 8.3 meters. Find the diameter of circle A dilated by a factor of 3. So simply all we're going to do is we want something that is 3 times bigger, so I can just say 8.3 multiplied by 3. 3 times 3 is 9, 8 times 3 is 24. We get 24.9 meters is going to be the diameter. That is 3 times bigger. Now I want you to try. Pause the video, give it a try. So circle B has a diameter of 12 meters. Find the diameter of a circle that is dilated by a factor of 3.4. 12 times 3.4, we get 8, 4, 6, 3, 1 decimal point, so 1 decimal, so I know it's going to be 40.8 meters. Boom, that's simple. Find the radius of a circle with area of 13.7 units squared, round to the 100th place. Okay, so this one's a little bit different. Find the radius. So we don't know the radius. So we're looking for the radius, and we know the area is 13.7. So first of all, we have to know that the area of a circle is pi times the radius squared. Now we can just fill in. So 13.7, we'll put in for the area. Pi times the radius squared. I'm going to divide both sides by pi, and I get 13.7 divided by pi equals the radius squared. Then I'm going to take the square root of both of those sides, and we get square root of 13.7 divided by pi equals the radius. We'll pull up our calculator here. We're going to say the square root of 13.7 divided by pi. Is that right? Okay. Let's get our approximation here. 2.088. 2.0882. So radius equal to 2.0882. Says round to the hundredths place. So let's see. We have our tenths and then hundredths. Okay, so I want to round to this place. So I'm going to look at this number. It's 5 or bigger, so it's going to add 1 here. So I'm looking for radius is equal to 2.09. And there's my answer. Okay, if you have any questions about how I did that, please come and talk to me. I'm happy to help you out. We'll see you next time. Have a great day.